Hello students, week 11 physics for grade 10, chapter 23, lesson number 4, boiling. Keep your textbook open, page 454. At the end of the lesson, you will be able to define boiling and describe how pressure affects boiling point. You learned what is evaporation. Evaporation is a change of phase from liquid to gas, and it takes place at the surface of a liquid. What is boiling? Boiling is also a change of phase from liquid to gas, but it is beneath a liquid surface. Kindly watch this video.
So as we add heat to water, the water molecules begin moving faster, and some of them spread out and form a gas. We call that gas water vapor, and that's what's inside the bubbles you see. These bubbles rise to the surface, and this is what we call boiling. So we'll start with the water molecule. The red is oxygen, and the two white atoms are hydrogen. That's H2O. Water molecules are always moving. When we add heat, they move faster, and if we add enough heat, they'll spread out and they'll form a gas. We call that gas water vapor. Note that there's nothing between the atoms here. The black is empty space. To understand why bubbles form during boiling, imagine a group of water molecules, and as you add heat, some of them spread out and form a gas, water vapor. When they spread out, they push the molecules around them away, and that forms the bubble that you see. That bubble rises to the surface. That's boiling. Remember, there are only water molecules in those bubbles. They're very energetic water molecules in the form of a gas, which we call water vapor.
Yes, as you saw in the video, the pressure of the vapor within the bubbles in a boiling liquid is great enough to resist the pressure of the surrounding water. You can see here, as the atmospheric pressure is increased, the molecules in the vapor must move faster to exert increased pressure to counteract the additional atmospheric pressure. What's happening in different pressures? At a lower pressure, boiling point decreases, and at a high pressure, you can see a boiling point increases. So kindly watch the next video.
Boiling depends on the amount of pressure around the liquid. On Earth, the atmosphere is what creates this pressure. If we look at a cross-section of the atmosphere, only 50 kilometers has enough air for humans to breathe. The pressure also decreases as we go higher. That's because as we go higher in the atmosphere, there are fewer air molecules. Like all matter, air has mass, and gravity pulls it towards Earth. That's why the atmosphere doesn't just drift away into outer space. The weight of the air above us pushes down due to gravity, and this creates atmospheric pressure. The more air above you, the more pressure, and pressure makes it more difficult for boiling to take place. Think of it like these books. The more books, the more pressure. And the more pressure, well, eventually, it'll crush the can. When you go up a mountain, there is less air above you pushing down, and the pressure is lower. Your ears can pop, and water boils at a lower temperature than it would at sea level. So back to boiling. Boiling happens when water molecules have enough energy to spread out and to form bubbles. These bubbles rise to the surface and they release the water vapor. Since the water vapor contains these more energetic molecules, releasing them into the air cools the water. So here we have our beaker with a bubble. If we increase the pressure, the molecules in the bubble will move closer together and eventually they'll change back into liquid water. Alternatively, if we decrease the pressure, that makes it easier for those water molecules to spread out and form a bubble, and that's boiling. We can see this with the syringe. We push in the plunger, we increase the pressure, molecules move closer together and the bubble becomes smaller. When we pull the plunger out, we're decreasing the pressure. That means those molecules can spread out more easily and the bubble grows. If we pull the plunger out and decrease the pressure enough, water will start boiling. Note that the temperature doesn't change. It doesn't get hotter when it boils. It's just that there's low pressure, the molecules can spread out to form bubbles, and that's what we see happening here. Boiling is strongly influenced by the atmospheric pressure. On Earth, that pressure is created by gravity, pulling air molecules down towards Earth. Those air molecules push on a liquid, and they can make it more difficult for boiling to take place. Remove the pressure, and it's easier for boiling to take place.
Yeah, as you saw now, there is a difference in the boiling point when there is difference in the pressure. Yes. Is there any practical application for pressure and boiling point? Yes, there is. We use pressure cooker at home. See, it is important to note that it is the high temperature of the water that cooks the food, not the boiling point itself. So how a pressure cooker works? So let's look at the next video.
The water in this pot is boiling, which means it has enough energy to overcome the air pressure above it and turn to vapor. Here in Boston, at sea level, water boils at 212 degrees Fahrenheit. But 1 mile up in Denver, Colorado, where the air pressure is lower, water boils at just 203 degrees. The boiling point of water is dependent upon air pressure. Inside this pressure cooker, where the air pressure is about double what it is at sea level, water boils at a whopping 250 degrees Fahrenheit. That higher temperature means shorter cooking times. Now, all pressure cookers have the same basic design: a thick base that helps distribute heat evenly along the bottom of the pot, a semi-sealed lid with a rubber gasket, and a valve that regulates the pressure inside. As the pot heats up, the pressure inside builds, trapped by that sealed lid and maintained by the valve. The water molecules inside need more energy to turn into vapor, which increases the temperature inside the pot. That super hot, moist cooking environment transfers heat to the surface of the food rapidly, cooking it faster than would ever be possible in our regular Dutch oven. So, why use a pressure cooker? The simple answer is that it's faster, but the results really speak for themselves.
Yes, you saw the video how a pressure cooker works. It's you can see in your textbook. A pressure cooker has a tight fitting lid that does not allow vapor to escape until it reaches a certain pressure. Okay, as you know, boiling is actually a heating process, yes, but in reality, boiling is called a cooling process. Why it is called cooling process? You can see at 100 degrees Celsius, water starts boiling and then energy leaves out. You all know that when the energy leaves out, it is called a cooling process. Okay, there is a question now to think. Since boiling is a cooling process, would it be good idea to cool your hot and sticky hands by dipping them into boiling water? Explain. Okay, your answer is no. Of course, it should be no. When we say boiling is a cooling process, we mean that the water, not your hands, is being cooled. A dip in 100 degrees Celsius water would be most uncomfortable for your hands. There is a question in your textbook. What is the effect of pressure on the boiling temperature of a liquid? Kindly try to answer this question. Thank you. See you next time.